see the 4 in front? I actually don't know if it's going to matter. Is the answer 0? So the 4 doesn't matter, but I could very easily see like not seeing that 4. Can I help you? Try to steal my. 25. So I'm looking. I see signposts, and it makes a dotted line. Oh, I just had to warm up.
Oh, you drew a line. It's not a curvy line.
No, that's out of line.
So
No, that's a curve.
it's a curve. So I'm looking at. I see signposts on it. I'm trying to get to these things somehow. So I see signposts, and one thing I notice is I can put that 4 just like on top. But if I could take a sine of x out of, like, reverse distribute, vector out a sine of x, what I would have left would be cosine of x minus 1. And then I've got x squared on the bottom still. And that gets, like, I can kind of see where I'm supposed to go now. Because I know sine of x over x is something I'm familiar with that I can do. Cosine of x minus 1 over x is one of the things we have rules for also. So I can kind of split up that bottom. I can rewrite this as 4 times sine of x over x times cosine of x minus 1 over x. And remember, this is all still the limit as x approaches 0. So the 4 is just a 4. The limit of sine of x over x as x approaches 0, remember you look at the coefficients, it's like 1 over 1, so that's 1. But then the limit of cosine of x minus 1 over x is 0. So that's why if you didn't see the 4, that's why it didn't matter, because you're multiplying by 0 anyways. So they kind of snuck it in, but it really impacted things. No, because if I were to distribute it back, so like let's say I said distribute this. Sine times cos would be sine cos. And then sine times negative 1 would be sine of x. And that gets me back where I started. Anything else on 1-6?
Every time.
10 cents in every time. We'll be able to go see a point on it.
You come out the amount of food for the garage.
Alright, let's look at 1-7. Pick out a couple in here, or you guys can tell me if you already looked at it, like, hey, this one looks rough. Any that you specifically want me to do, or should I just pick like a couple of each that look representative? Well, those are the notes, right? So,
6. Yeah.
6? Okay. It's easier. It looks, you're right, it does look easier. So, you can look at this a couple of ways. Like some people like to write out what's actually happening, and maybe that'll make you understand what's going on better. But I could factor out an x to the 4th for both the things on top. And if I do that, you're essentially dividing everything by x to the 4th. So I'd have 2x plus 3. And on the bottom, I just have x to the 4th. Well, what's going to happen to those x to the 4ths now? Is they'll cancel. And now I can just plug in 0, and 2 times 0 plus 3 gives me 3. Some people would look at it and just right away jump to like, oh, I can just like cancel. You're allowed to cancel as long as you're canceling some people make a mistake of like let's say I had this 10 minus 20 plus 30 over 10. Could I rewrite that as 1 minus 2 plus 3 over 1? I could. I divide everything in there, every single thing in there by 10. But if there's like a plus 4 there, can I do that? Now you're not being fair, right? You gotta do it to every single thing. So as long as you're able to do it to every single thing, you can just straight up cancel it. So you could just, right here, I'm gonna just chop x to the 4th out of each one. And then you can kind of jump to 2x plus 3 over 1 and do it that way. So this is what you're really doing if you do that. Some people help like see that. Some people just jump to that. That's easier. But whichever. And some of these on here, don't forget, what's the first thing you always try with the limit? Just direct substitution, just plug it in. Very often you're going to end up with 0 over 0, and that means you got to try another way. But there's also times when like you're just going to get the answer. I get a ton of questions on, so we'll do all this like rationalizing. We're about to do rationalizing and like complex fractions. And you got all these different methods, and then after you learn that, I'll give you a problem like this, and you're like, I don't know what to do. Well, yes, you do. You just kind of forgot. Like you just plug it in 2 squared is 4. So don't forget the first thing you always try is plug it in. Then, if you get 0 over 0, try to find another way. I do want to do like at least one of the rationalizing and one of the complex fractions. I'm going to do number 5 unless anyone has like a different one you have in mind. Alright, so x plus 9.
Wait, will you do one of the double fraction ones too?
Yeah, I'll do one of each though, at least one of each those. Okay, so I think I can squeeze that up here. Limit as x approaches 7 of the square root of x plus 9 minus 4 over x minus 7. So try and plug it in. This could be like a trap. You don't actually have to rationalize. But let's see. 7 plus 9 is 16. Root of 16 is 4, so 4 minus 4 is 0. So you will get 0 over 0 if I plug it in. So we're going to do what's called we're going to multiply by the conjugate. So we know, just kind of a side note over here, if I have like x minus y, and I want to end up with x squared minus y squared, what would I multiply by? X plus y, right? Just to like prove that works, that'd be x squared, that'd be positive xy, that'd be negative xy, that'd be negative y squared, and then these would cancel, and we do get x squared minus y squared, right? So why am I going through this? Well, I want this square root to be gone. So I basically want it squared, right? If I square it, if I could get that thing squared, there wouldn't be a root anymore, and that might make things easy. So I'm going to do that same process. I have this chunk here. I'm going to multiply by what's called the conjugate of that, which is you write down this term and this term the exact same. You just change that to a plus. Or if this were a plus, you make it a minus. So I'm going to multiply by root x plus 9 plus 4. If I do it to the top, I've got to do it to the bottom also, right? So now, if we multiply through on top, think about what we just did. The 2 middle terms are just going to cancel. So we're going to get the first term squared. So what's root x plus 9 times root x plus 9? X plus 9. Like think about what's root 100 times root 100. That'd be 10 times 10, which is 100, right? So root x plus 9 times root x plus 9 is x plus 9. Then you would have positive 4 times root x plus 9 and negative 4 times root x plus 9. So what would happen to those two things? They just cancel out, right? And then you have negative 4 times positive 4, which is minus 16. With me? That's kind of like the key step. Then on the bottom, don't try to multiply this through. just make it harder for you, I'm just gonna leave it because I can kind of see right now, and you'll get better at it the more you do. That is gonna simplify to be x minus 7, isn't it? And I've got an x minus 7 right here, so it's gonna cancel. Where if I like distribute this through, you won't be able to see anymore. It's gonna cancel. So here I have x minus 7 times root x plus 9 minus 4. So what I really have at this point, yes, thank you. This should be plus 4. Thank you. What I really have on top is just x minus 7. And on the bottom, I still have all this stuff. Again, don't distribute through because then it's way less obvious that these two are the same and that they'll cancel out. You with me? Go over this again. Where'd you get this? Why did you do this? What day is this? Okay. So now these cancel. You have to have something on top of the fraction, so what goes there? There's 1. So what you essentially have now is the limit as x approaches 7 of 1 over the square root of x plus 9 plus 4. And the thing that was giving us 0 on the bottom was the x minus 7, right? If you plug 7 into x minus 7, you're going to get 0. Well, I just got rid of it. So I'm now able to plug in, and I won't get 0 on the bottom anymore. So now you plug in 7, so it'll be 1 over the square root of 7 plus 9 plus 4. So the square root of 16 is 4 plus 4, so this will end up being 1 over 8. How's that? Questions on that? Let's try this. Well, I want you guys to do one of those, like on here, and then I'll do it up here, just so we can practice another one, and then I'll do the complex fraction one after, and we'll kind of do the same thing. So, if you haven't yet, go ahead and do number 1. Yeah. And I mean, there was no reason you were supposed to have, so don't feel like you haven't. You're in a bad place or something. I just know some people probably were. Nerds. So it's the same idea. You're going to multiply by the conjugate. You're having trouble getting started. And then we're a fair society, so whatever we do to the top, we do to the bottom. Did you throw a perfect game or is that a good name? Yeah, I think yeah, I've got like 5 more. It's 1 over 2 root 7. Or you could leave it as like 1 7 plus root 7. I'll do it. I'm just waiting. Okay. So again, start by trying to plug in. It might be that I go through all this process I didn't even need to, which would be a waste of your time. Time is going to be an issue on your tests, on the AP test. So you want to save it when you can. But if I plug in 0, I'll get root 7 minus root 7 on top, which is 0. I'll get 0 on the bottom. So I do have to find another way. So then I'm like, okay, there's square roots there, so I'm going to try to rationalize. Rationalizing is this process. So I'm going to multiply by the conjugate of this. And then I know I'll have this times this, root x plus 7 times root x plus 7, which is x plus 7. I know the middle two terms in the FOIL will cancel each other out, one positive, one negative. And then positive root 7 times negative root 7 is 7. And it was a negative times a positive, so it's a minus. And then on the bottom, don't distribute. Leave this here because it's way easier to tell that things are going to cancel. Bless you. And then those 7s will go away, right? So on top I just have x. On the bottom I still have x times all this stuff. And then the x's go, but you have to have something on top, so you leave a 1. And then you plug in. Now we can plug in 0 without running into an issue. And you could actually, like, this is a completely valid answer right here. You could leave it. On a multiple choice, you'd be able to match up. So let me just make sure here. Is it A or B? It's A, right? Like some people try to, like, if you multiply root 7 times itself, like what's root 7 times root 7? It's 7. But root 7 plus root 7 is just like, you know, if I had x plus x, I get 2x. So root 7 plus root 7 is 2 root 7. If I have grill out, chill out plus grill out, chill out, I have 2 grill out, chill out. Is 1 okay? Less than 1? So 2, do you have to rationalize? Do you have to do like the conjugate deal, all that stuff? Just plug it in. Answer number 2 is just, I plug in 1, I get square root of 5. I didn't get 0 over 0, so I'm done. But let me do 3. It's 3 the complex fraction, which just means like a fraction on top within another fraction. It tends to mess people up. So let me back up a second, and let's say we had 1/4 minus 1/3. What's the common denominator? 12. So what would I have to multiply this fraction by? Say you multiplied it by the bottom of the other fraction. And then what would I multiply this fraction by? So you say you multiplied it by the bottom of the other fraction. And then I would get 3 minus 4 over 3 times 4, which I know is 12. But I'm just trying to like keep it consistent for this one that we're about to do. So limit as x approaches 0 of 1 over x plus 3. I'm going to leave some space, but I know I got to multiply some things there. Minus 1 over 3. All around. So my common denominator with when I had 3 and 4 was 12. So essentially we just multiply those two numbers together. 3 and 4, 3 times 4 is 12. So the common denominator here is going to be x plus 3. This is what I want to be in the bottom at the end. X plus 3 times 3. So I'm just going to multiply those together, just like I multiplied like the 3 and 4 together to equal 12. That's what I want to be in the bottom. So for this one, what do I need to multiply by on the bottom to turn into that? I need to multiply by 3, which is again just the bottom of the other fraction. But if I do it to the bottom, I gotta do it to the top. I left a lot of space there. Same thing here. If I want this to look like this, I want to multiply it by x plus 3, which is just the bottom of the other fraction. So now I will end up with the limit as x approaches 0 of 3 over 3 times x plus 3 minus x plus 3 over 3 times x plus 3 all over x. And you're like, okay, you just made it like look worse, which I agree with, but we're getting there. So the two things I have up there, like the left stuff and right stuff, are the exact same. They're just written on the right out of common denominator because now I can combine them on the next step. On the left, I didn't have that, so I couldn't. With it. So then I will have the limit as x approaches 0. Remember when you subtract fractions, you leave the bottom the same. So if I had like 4/12 minus 1/12, it would be 3/12, right? 4 minus 1 is 3, and you leave the denominator the same. So what I would have on top here is 3 minus x plus 3. Make sure that x plus 3 is in parentheses. Because when I write it in parentheses, what's going to happen to those 3's? Yeah, isn't this 3 actually negative? Because of the negative sign in front of the parentheses. If you forgot the parentheses, they're not going to cancel. You'll have like just a positive 3 there. So I have this. And then I'm going to do something else. Well, no, I'm going to wait. This is all divided by x. Still have that x on the bottom. I don't want to jump too much stuff. We good there? So then this is really like, if I distribute that negative, it's 3 minus x minus 3. So isn't that just x? That's all still over x.
Wouldn't it be a minus x?
Yes. Thank you. So these 3's went away, and then minus x there. Still good? So I have this fraction on top divided by an x on the bottom, but you don't divide fractions, right? You invert and multiply. So instead of dividing by x, I'm going to multiply by 1 over x. I'm showing like the extreme most amount of work you possibly could. Like the more you do, you'll start like simplifying and shortening these. I just don't want to skip steps and like lose it. So common denominator. Then I wrote out what that was. Then I combined them, subtracted the 2 fractions to get here. Then I simplified the top. And then instead of dividing by x, I multiply by 1 over x. So now what's going to happen to those 2 x's? Let's go one more. This might be overkill, I don't know, but when you multiply fractions, you go straight across the top and straight across the bottom. So on the top I have negative x. On the bottom I have 3 times x plus 3 times x. So what happens to those x's? You got 1 on top and 1 on the bottom, right? So they will cancel. Again, this problem is not that long once you do a couple of them. This is not short, but it's not this. So now I am at limit as x approaches 0 of what's on top of that fraction now? Negative 1. On the bottom is 3 times x plus 3. And finally, I'm at the point where I can plug in the 0. And then I can just like work out what that math is. But with this x being on the bottom, I couldn't plug in the 0 because I get 0 down there. But when we got to here, we were able to cancel that x, and now I can plug in. Yeah.
So as long as the 0 is on top, you can direct substitute. Like if there's like,
If it's like 0 over 5,
yeah.
that's 0. Yeah. You got $0 divided up evenly among all 5 of your friends, and we all get $0. So that, like that's a legit number. That makes sense. I said we. I don't know if we're friends or not. Yeah.
Where
So when you're dividing fractions, like let's say I had 2/3 divided by 4, we don't do that. We flip over the bottom fraction and we multiply. So like dividing by 4 and multiplying by something by 1/4 are the same, right? You get $100 divided by 4, 4 multiplied by 4, you get 25. So that's what I'm doing here. I'm not going to divide by x. I'm going to flip that over and instead I'm going to multiply by 1/x. That gets you there. What else? Where in there can I go through? Clarify this. I don't see where this happens. Why to do this? I think you screwed up. Anything? Alright, so let's do that kind of same process again. Let's pick out another one of those. Let's say number 7. If you haven't yet, I'd like you at this point to try number 7. Does everybody need this up here like the work from the last one? The what? Oh, I'm just trying to learn. I throw in this extra. Because that, you got this 4 minus. So let's say I have like 4 minus 3. What you're saying is you cancel out, right? So it's got to be in every single term.
This is before.
Oh, okay.
That's what I'm doing right now.
So you're ahead of the other.
Yes. This is so weird.
Whatever. The average out of it.
Calc is so much easier than advanced stats.
Really?
Yeah. I don't know
You also
why.
solve this stuff last
Yeah,
year,
like this is
so-
stuff that I know, and it's fun. I like the long. I don't like word problems. There's lots of.
Yeah. That's my favorite book. I mean, there are some word problems in Calc.
That's just different math.
Concepts. It is.
Because like compared to like pre-calc from last year, like this is like pre-calc, so I like it.
Yeah, yeah.
The stats is like completely different. So like, I don't have to like rewire my brain to do this.
As we get going, sometimes not even math class.
It's like
It's almost like logic, science.
which is cool. Like I like that.
Yeah, it's different.
It's just different. So obviously it's struggling with it more than calc.
Am I gonna do it through this one, or am I gonna wait a little bit first? Okay. So my common denominator is gonna be x plus 6 times 6. So I essentially need to multiply each fraction by whatever's on the bottom of the other fraction over itself. So like I'm gonna multiply this by 6 over 6, and this by x plus 6 over x plus 6. So that will give me. So I'll shorten up the steps a little bit this time. That'll give me x over. On top, I will now have 6 minus the chunk x plus 6 over 6 times x plus 6. Right? And then what that really means is I have x over negative x over 6 times x plus 6. So then there's that rule that we don't divide fractions. We flip over the bottom fraction and multiply. Yeah. You're gonna be freaking kidding me. I did it. You don't even have to do this. I'm gonna go through anyways. We better get saved. I'm gonna go through anyways just to like practice the process. But yeah, I didn't even. I fell for that thing that I told you guys. Like it looks like I'm supposed to do all this, so I started doing all this.
They
But
did on the note on the entropy.
did they?
Yeah.
So if you plug in, you don't get 0 over 0. You get 6 over like 1/12. So is it 72?
Yeah.
Yeah. Let's make sure we get the same thing. Our process works. So then I'm going to. I don't divide fractions. I flip over the bottom fraction and multiply. So this becomes. Yeah, if you had Porter, he said like keep change flip all the time. So let's keep the first fraction, change the division to multiplication, and flip the second one. And then these will cancel. So you get 6 times, what is it, negative? Negative 72? Over negative 1. And then you can plug in 6. So 6 times. It's not going to work. What did I do?
They wouldn't have done it if it worked, I don't think. Right? So there has to be something that doesn't work.
Yeah.
No, it's 6 plus 6 is 12. I was like multiplying them. So it's negative 72. Okay. Yeah, yeah. I was doing like. So that's like a trap that you might fall into. The same one I just did. Like you're on the AP test or your test, and here and your time's running out, and then you could do this problem in like 30 seconds, but you took 5 minutes. So it's just like you gotta remember to direct substitute first. I'm not exactly demonstrating that very well right now, but maybe you can learn from my errors. That's all I wanted to do. I wanted to give you as much time as I wanted. I wanted to give you some time to work on it. Should have 1/7 done. Today, and then we'll see where we're at tomorrow. Let's do, yeah, so 1/7 done today, 1/8 notes for tomorrow. Or no, 1/9. We're skipping 1/8. Yeah, skip 1/8. I'm gonna squeeze it right out of here. So sounds good. 1.8 notes for tomorrow. So we're getting to the 1.9 is the last section. So we'll probably have a test like quiz like Monday. No, sorry, not Monday. Probably Wednesday.
That's nice. No.
So I'm thinking like we might take 2 days to do the next section. Or we might need more time for this tomorrow.